if an alternating series converges, which means S sub n plus 1 is less than S sub n, and the limit of S sub n as n approaches infinity is equals to 0, then we can say that the absolute value of the remainder involved in approximating the sum of this series is less than or equal to the first neglected term. Okay, so remember here we're focusing on the amount of error, and we're saying that it's less than or equal to the first neglected term. Now remember, this theorem only applies to alternating series. Okay, so it's valid only for alternating series. Now I'm going to explain in this example how to go about solving this, applying this theorem. So remember, the first step is to check that the series converges. So step 1, check if the series converges. Okay, so to check that the series converges, if the series converges, we have to check that S sub n plus 1 is less than S sub n. Now in our case, S sub n plus 1 is 1 over n plus 1 factorial, and S sub n is 1 over n factorial. Now if you look at these guys here, we can see that 1 over n plus 1 factorial is less than 1 over n factorial. So we can see that 1 over n plus 1 factorial is less than 1 over n factorial, because n plus 1, that's a bigger number, and if you're taking the reciprocal of that, it will definitely be smaller than 1 over n factorial. So we can say that S sub n plus 1 is less than S sub n. And that's one of the conditions that we have to check for convergence. Another condition that we have to check for convergence is the limit of S sub n. Now, the limit of S sub n as n approaches infinity, that will be equal to the limit of 1 over n factorial as n approaches infinity, and that will be equal to 0. So because of these two facts here, we can say that this series converges by alternating series test. Hence, this series, or I can say therefore, the series converges by alternating series test. Okay, now that we know that this series converges by alternating series test, we can go ahead and try to find the approximation of the sum. In this case, correct to 3 decimal places. So that will be our step 2. So step 2, we are going to find the sum of the series correct to 3 decimal places. Okay, so we know that this series is equal to, we are finding the sum from n is equals to 1 to infinity, of negative 1 to power n minus 1 over n factorial. Now let's try and produce some terms of this series. We can try to produce the first 6 terms of this series and see what happens. So the first term will be, you just plug in 1 in place of n, so you just end up with 1, plus negative a half plus 1 over 6 plus negative 1 over 24 plus 1 over 120 plus negative 1 over 720 plus 1 over 5040. And this goes on and on and on. Now remember what we said, that the absolute value of the remainder is less than the first neglected term. So we want to find what will be the first neglected term, so that the error that is involved is less, such that the sum that we'll be finding will be correct to 3 decimal places. All right. So the first thing is, let's try by inspection, just try to find out what the value of this will be. So if we find that, just plug that in your calculator. That will be, let me just create more space here. So this will be negative 0.001388. Now, if you work out that, this will be 0.0001984. Now remember, we want our answer to be correct to 3 decimal places. Obviously, our cutoff point will be after 3 decimal places. So basically, our cutoff point will be there, and it will be there. And if you check by inspection, you can see that this one here will give us an error that's less than, in fact, the at most error, the error will be at most 0.0001984 in this case. All right. So if we take the first, how many terms are this? If we take the first, if we take this is up to here. If we take that sum, let's call it 1, 2, 3, 4, 5, 6. The sum of the first 6 terms. The sum of the first 6 terms will be correct to 3 decimal places, because the error is at most 0.0001984. In fact, this one here is our neglected term. Okay? That will be our neglected term, such that the error is at most 0.00194, so that the sum S6 is equal to the sum of the series to 3 decimal places of accuracy. Okay? So this is equal to, if I can just write, so S6 is equal yeah, everything's correct. So S6 is equal to S correct to 3 decimal places. All right. So remember, we are trying to estimate the sum of the series. And what you're saying here is the sum of the first 6 terms will be equal to the sum of the series correct to 3 decimal places. Why? Because the error is at most 0.000198 when we approximate the sum of the series to correct to 3 decimal places. Okay. So here what you're saying here is okay. So what is the sum of the series in this case? Correct to 3 decimal places. So we'll have to find S6. So basically you just add all those guys. So S6 will be equal to, if you add the first 6 terms using your calculator, that should give you 0.631944. And this is correct to 3 decimal places.